Hello friends and welcome you all in this video. So this is the introductory video for the those who are uh, trying to become the data engineering and those who are trying to get into data engineering, or some of you are trying to transition from any kind of profile from the IT background to the data engineering, and some of you, if you are trying to get into anyhow into the data engineering, because the data engineering is the right now very trending profile in the market, in the corporate sector, in the future also. So if you are trying to get into data engineering, so trying I'm also trying to help you out to transition your career into data engineering. And some if you some of you are trying, or some fresher students also trying to get into data engineering. So, let's get started. Uh, why data engineering? Because the right now very the trending job and sexiest job in the corporate world is around the data engineering only. It has very high demand in the market and also high packages also. So you need to understand the clearly what skill set you require for to become the data engineer, and what depth you should have to crack the interview and to work into the IT sector as a data engineer. So this video, initially I'm going to give the basic idea about the data engineering, how the how you can become the data engineer. And just I'm going to mention the only few skill about the data engineering, which is very much required to become the data engineer. And then I will start for the actual lecture. Then I will start for the actual lecture, that is around the data engineering. So you should have the two skills. One is skills. I'm mentioning the skills here. The first one, you should have the, I'm increasing the font little bit so you can see it clearly. First, you should have the Python language base, or if you have the background of Java or C plus or C language or Scala, all these languages are fine. You can have the reference of these languages. And because the Python is very much famous in data science background, so if you have the Python background, it's good to go. And if you don't have the Python background, you can learn the Python basics, not in depth like a software developer use that much. You just need to understand the basic to intermediate level only. The second one is the very important is SQL, structured query language. So SQL is a bread and butter for all the data profiles like the data engineering, data analyst, data scientist, and all that. So you need to understand SQL from basic to intermediate, intermediate to advanced level, all these levels. But basically, you start it from basic level to the intermediate level. So these are the two, I can say these are the prerequisite to become the data engineering. And then afterwards, you can have a lot many skills to become the data engineer. So the first one is the Hadoop. Second one is the Hive. Third one is the most important, I can say it's Spark framework. And apart from this, I will mention the important one is any cloud, any cloud, any cloud like Amazon Web Service or Azure or GCP, Cloud, Google Cloud Platform. From these three clouds, you can choose any one of these cloud and try to understand the basics of basic services of these clouds. So the all the corporate market, industry market is revolving around the Azure and AWS. You can choose the anyone from the AWS and Azure one, because GCP don't have that much of recruitment. So you can choose from Azure or AWS one, or you can parallelly. So if you are beginner, you can choose uh, anyone from AWS or Azure one. As part of India, Azure is the trending one, and apart from the US market, I can say AWS is the trending one. So these are the skill set required for. These are those very basic skill set, I can say, to become the data engineer. So uh, I'm going to start uh, for this lecture from very beginning of the course, I can say. So just give me a second. I will be highlighting here. I'm going to start with the what is a big data? You know, have you heard about the big data? So what is big data? Have you heard this word before? So what is big data? Okay. So we are going to start from here. The in IT industry or IT sector, we are having the large amount of data, and we are revolving around that data. We are having the data. We can by using that data we can scale our business. So so the data is very important, and data is very important. What volume of data we can say? Big data means large volume of data, actually, in very layman terms only, but that is not the actual case. Large volume of data is called as a big data. That is not the correct one. So to define the big data, there are three ways. Three ways are there. Three ways. Three ways given by the IBM Software Foundations. Based on this, you know, IBM has given the three ways. Based on these, we can define that data as a big data. So, what are those three V's? The first V is a volume. Volume. So, to to give the data definition as a big data, or to specify the data as a big data, we should have that volume of data, or we can say large volume of data called as a big data. If the data size is very much big, so we can say it as a big data. So I'm giving the first V as a huge, sorry, huge volume, volume. of data is called as a big data. This is the first way. And what is the second way? Second way is a variety. Have you heard the word variety before? Yes, many of you heard the word variety. Variety means actually variety. Variety in the sense of data. So data has the variety also. Like data has a structure. Data is a structure. Data is in the structured format. Data is in the semi-structured format, or data is in the unstructured format also. So what are these three terms? Structured, structure, or semi-structure, structure, and third one is a unstructured. Unstructured. Okay, these are the three terms. Okay, first one is a structured data, second one is a semi-structured data, and third one is a unstructured data. What data called as a structured data? So listen carefully. Many of the expert in data engineering, they also got confused around this area. So structured data, uh, the data which follows the RDBMS format, relational database format. In simple language, we can say the database tables. Database tables has the rows and columns that are very clean and very in a structured format. We can call this as the structured data. The database tables or database RDBMS format data are called as a structured data. Uh, let's say there is a one table called as employee, which has the name, uh, employee ID, employee name, employee salary, employee age, the columns, and there are some different rows. So all these data are in a structured format. This is called as structured data. And semi-structured data, semi-structured nothing but uh, the data which has the format of JSON format, XML format, and CSV format. These data are called as a semi-structured format data. Okay, and what data called as an unstructured format? The data don't have any structure along with that data. So uh, video for video data don't have any structure, and images also don't have any structure, and logs files also don't have any structure associated with it. So these kind of data are called as a unstructured data. These are the three different types of the variety of the data. So basically two ways we have seen. First one is a volume. The large, the data should have the large volume, that is comes under the big data. Second one is the variety. That data should have the variety or structure associated with that, like a structured data, semi-structured data, unstructured data. Majorly data engineers are dealing around the semi-structured and unstructured data. They are uh, extracting that data and transforming that data into the structured format, and that structured format data goes to the some enriched level, and on top of that we can the data science people use that for their business purposes. Okay, so up to this two V's are we have seen. Third one, we can see the third one is the velocity. Velocity. Okay, the velocity is a velocity, but what it makes sense in terms of data engineering. Suppose I'm given one example here, so you can uh, relate that example, and you will have the understanding about that. Listen carefully. Suppose uh, there is an e-commerce site which runs the big billion sale, like a Flipkart, Amazon, or something, anyone the side you can choose. The side that choose the big billion sale, and on that particular day, there is a huge volume of data comes. Okay, and at that time for that day, the data speed is very high. Let's say in the morning, Amazon Amazon has a big billion day, and Amazon started the big billion day, and since from the last 1 hour he started the big billion day. So at that time, after the 1 hour, after the 60 minute, it has to analyze. Amazon has to analyze what what exactly the product he has sold out, and he want to show that sold out product to the customers with very minimum time and with very high speed. He has to reflect on the customer side to show them what kind of product they have sold out within a 60 minute. So within a very much short span of time, they have to uh, uh, analyze that data. So that is called the velocity. The velocity, the data which comes at a very high speed, and they have to reflect back to the customers what on the exactly what they have sold out. So they are trying to show at a very high speed. So that there is a velocity along with the data also. So you need to understand the three V's. First one is a volume, is the high volume of data called as a big data. Second is that big high volume data, huge volume of data, also have the variety. And third one is the velocity. That data comes in the high speed, high velocity, and comes back with the some analysis. This kind of data, these three V stand for the volume, variety, and velocity. So if this data follows this kind of uh, uh, terms, three V's terms, so this data called as a big data. So I think you have the much clarity on the what is the big data. So there are also many ways, like 5 ways in the market, 11 ways in the market, but don't you don't need to worry about those other ways what they are exactly mean, but you just need to understand three V's. If you have understanding about the three V's, what the three V's actually mean by, so you can understand that also. So uh, there are some systems in the data engineering. So if you have the data, uh, let's say there is a huge volume of data you have. Let's say suppose there is a 100 GB of data is there, 100 gigabytes of data. Okay, 100 gigabytes of data you have. This is the very high volume of data. So to to store this data, what kind of system you follow, what kind of architecture you follow to store this data, because 100 GB or in future the this data is going to scale. Scale means the data volume is going to be increased in the future because the depending on the business scenarios I can say. So there are two systems. One is a monolithic, and second one is a distributed. Okay, what these terms means? So these are the systems which follows in the data engineering. Monolithic is the term. Monolithic means the one single architecture, one single machine, or one single resource holds all the resources. The resources meaning here is like a, okay, Resources, I will write it down. Resource means the course course. Second is a RAM, and third one is storage. Okay, these are called as the resources. So the our previous system or older system used to follow the monolithic architecture. In monolithic architecture, one single machine has the all the cores, RAM and storages. Okay, so the single machine has all these like our system has the 4 cores, 8 cores, 16 cores like that, and uh, 8 GB of RAM, 16 GB of RAM, and storage also. We will have the like a 1 TB and something. These are the these are called as a resource actually. So in monolithic architecture, one single machine has the all the resources. So one single machine machine has all power. We can say all power. Power means resources or power. So the data, if you're not having the enough of data, so we can use this single power machine or monolithic system to handle that large volume of data. But what if the data in future it grows, scales? At that time, our system or a monolithic system or single machine is not going to handle the large amount of data. So in that case, we need to have the system which handles the large volume of data, which furtherly in future that going to scale the data, and that scalable data needs to be handled in the correct way. So we need to have the correct architecture. So what is distributed architecture? It is completely reverse to monolithic. So all the power, the cores, RAM and storage are distributed in uh, in sub uh, in sub parts of the machines. Like we can say in sub parts of machines means there are nodes. Nodes, we can say uh, 10 nodes of cluster. 10 nodes of cluster means the there are smaller machines which holds the data. The smaller machines, 10 nodes means 10 computers. In simple layman terms means 10 computers handles the large volume of data, or it handles the 100 gigabytes of data. To process that to process that 100 gigabytes of data, we are using the 10 node cluster. Are you getting the point? So 10 nodes means 10 computers, and 10 computers have their own cores, RAM and storage also. So it is very easy to handle that amount of data, and if we handle that large amount of data in and and if we store that data in distributed format, it is very easy to process also. After storing that data, we need to think about the processing as well. So it is very important to store the data, to use the system or to use the architecture in correct way. So majorly the industry trend is they are using distributed architecture system. So I think you are having the understanding about the systems what we are using right now. So uh, after having this, if suppose let's say we are having the 100 gigabytes of data, and to store that data we need a system like monolithic or distributed. So all the recent industry trend is they are all of them are using the distributed system because the data we cannot uh, we cannot uh, store in a monolithic format because you know it don't have the true scaling because in future data got gets like a, scaled or data may be increases. So this is not the monolithic is not the correct architecture to follow. So we are using the distributed storage to store the data. In a storage perspective, storage we are using distributed storage. We are using the distributed storage. Okay. So distributed means let's say we are using the 100 or 10 node cluster. Okay. We are using the 10 node cluster. 10 node cluster. That is that means we are using the 10 computer or 10 computer or 10 machines. And let's say we are having the 100 GB of data and that 100 GB we are going to equally divide in 100 GB of data we are going to divide on the basis of these nodes. 100 divided by 10 means it's 10 GB. Each node holds the 10 GB of data. So it is very uh, easy to distribute the data from in 10 nodes. Each node holds the 10 GB of data. And to process these 10 GB of data in that single node, we need to think about the processing as well. So to process this 10 GB of data, we need to have uh, some technique to or computation technique or processing techniques that is called as a uh, distributed distributed processing. Okay, so this is called as a distributed processing. What that exactly means, out of 100 GB of data we are using the 10 node clusters and each node holds the 10 GB of data. So to process this 10 GB of data we need to have some distributed processing because why we are using this distributed processing or Python code or Java code are they are working on for the single machine only. They are not work on the like a distributed processing. What that means? If we write the Java code or Python code, that code only process the data on that particular machines. They are not uh, going to process the any other nodes. Okay, so we need to have the distributed processing. And third one is we need to have third one is a scalability. Okay, scalability. What is this scalability means? Scalability means right now you are having the 10 GB of data and that comes from the one site or any one source. In future that data or sources of that data is going to be increased in the future. So at that time the data volume is going to increase in the future depending on the uh, what sources you are increasing. So to handle that data we need to have we have to plan in that way the data scalability right now. So these are the three terms we need to take care of before uh, going for the data storage and data processing. We need to think about this those terms. First one is the system, the what we are going to use in data engineering. We mostly right now preferring the all the industry are standardized right now. They are using the distributed. No, mm, no single organization going to use the. They are not using the monolithic system. Okay, the and uh, if we are thinking about the storing of the data, we need to think the data must be in the distributed format. In the distributed storage, data should be get exactly divided among the what the number of nodes we have. We call it as cluster. And to process that distributed data, we should have the distributed processing. Okay, distributed processing. So because we are not having the single machines, and Python code and Java codes, they are work on the single machine. They are not work on the distributed yeah, storage. So, and third one is that we need to take care of the scalability of the data. So these are the main things in the when we are defining the uh, data, uh, defining the big data. So we have seen what is the big data. There are three V's of the data which are given by the IBM. First V is a volume, second is a variety, third one is the velocity. And we have seen the systems or architecture, monolithic system or distributed system. Mostly the organizations follow the distributed system. And what is the resources? Resources meaning is the cores, RAM and storage are called as the uh, resources. And storage perspective, we we need to store the data in distributed format only. We cannot store the data in the single machine. And to process this distributed storage, distributed stored data, we need to have the distributed processing. And third one is the scalability. So that's all for this lecture. And I think uh, you have some basic understanding about the data engineering in this video. In upcoming lectures, I will try to deep dive into the uh, actual tech stack. I'm just in this lecture we just seen the overview of the what is the data and what is the big data and what systems they are using and just all the very basic things. Okay. In next lecture we are going to see the actually what is the actually this skill set and what is the Hadoop, Hive and Spark on all of these. So for to understand to transition to the big data, I'm going to provide you free resources on the YouTube. Try to follow this. Thank you so much.